We are Team B186, Kaylee, Oisan, Zoie, and Elizabeth from Diocesan Girls School, and here represents StrikeLogic, an IoT bowling ball that turns every roll into real-time telemetry.
The setup is made out of ESP32, MPU1950, and TP5100, powered by two lithium 3.7B batteries. ESP32 is the brain of our ball, handling physics calculations, and comes with an integrated 2.4 GHz Wi-Fi for users to connect to the ball with their devices. Our sensor is the MPU1950 and contains an accelerometer which detects G-force. It also contains a gyroscope which measures how fast the ball is rotating around its internal axes, giving us the amount of revolutions the ball per minute. With the two sensors combined, we can also obtain the axis of tilt and rotation of the ball. Lastly, TP5100 is a power management system that allows us to safely charge our batteries, allowing the ball to be powered.
Inside the clear bowling ball, we engineered a custom Nicesium cubic housing in Blender. By centering this core, we aligned the MPU950 perfectly with the ball's geometric center. The internal architecture features structural columns to dampen vibration and decrease the risk of breaking, while other components are dedicated to the side panels. We integrated 3 extra counterweights to maintain a perfect center of gravity for our cubic housing.
For displaying the data, we have created an app through Flutter. When the ball is turned on, the ESP will act as a hotspot, and we will need to connect our device to the ESP. Then, we enter the SSID and password of the network that we want our phone and our ball to communicate through. This information will be sent to the ball to the hotspot connection we've previously made. The ESP will then reboot and connect to the network, and we will have to enter the IP address and the port of the smart chip, detect and receive future processed data back to the app. For now, it's a static IP address. After everything is connected, press the live section. Connected to ball can be seen at the top, and now it's time to bowl. In the stats section, users can check back on their own personal data from previous shots to examine their progress. The app also calculates the average for users. And with this app, each shot becomes a measurable step towards a better game.
Our current prototype is just the beginning. Our final product is a triple layer mimicking a standard bowling ball. First, the core will be cast in epoxy, acting as a high-density core. Followed along, the head cage made of resin to hold the cylindrical balls at the center. Lastly, the Otis shell, 78D polyurethane, which is the exact cover stock for urethane bowling balls on the market, allowing the ball to react when facing friction when it is on the lane. And with all components together, this will give us a standard 21.8 cm diameter bowling ball. The AI acts as a virtual coach, turning raw bowling data into clear, actionable advice. Instead of just displaying stats, the system explains why numbers like rev rates change and provides specific tips to fix a release, allowing users to have personalized guidance.
One of our most ambitious future developments is camera-less path tracking. Unlike traditional systems that relies on expensive lane-side cameras or using motion tracking with Fung lens, StrikeLogic uses interior dead reckoning. By fusing data from the MPU9250, our algorithm calculates the ball's exact trajectory, allowing us to map the ball's path across the board with a high precision, entirely from inside the ball. To benefit a larger population of enthusiasts of different sports, our next phase is to have our chip retrofitted into various existing professional bowling courts. Moreover, having already overcome the technical hurdle of surviving high-impact sports, we foresee that the StrikeLogic core is going to be adapted to other ball games, such as football and basketball, and maybe beyond.